For today's lesson, we're going to introduce a topic that may be fairly new to most Algebra 2 students. What we're going to discuss is something called a matrix. Now, a matrix is really just an arrangement of numbers in rows and columns. If you think of matrices, and matrices is the plural of matrix, matrices are simply kind of like an Excel spreadsheet, if you will. If you took a block, a handful of cells from an Excel spreadsheet, and you have rows and columns, and you kind of grouped a set of numbers together, that's kind of like what a matrix is doing. Now, a matrix can represent any number of different real-life scenarios where you want to just pull the numbers and do some basic operations with them without having to have all the extra variables and stuff that go along with it. So what we're going to focus on here in our first lesson of matrices is just how matrices are set up, what the common terminology is around them, and how we can just simply do matrix operations like addition, subtraction, and multiplication. And so once we lay that foundation of knowledge of how to work with matrices, how to use our calculators with matrices, then we can introduce how they may be used in more application problems from the real world. So let's just start with what a matrix looks like. Now, we will identify a matrix by a capital block letter. So you can see here in our first example we have A equals, and then these matrices are written with these squared off brackets, and so any grouping of numbers in these squared off brackets in rows and columns will create a matrix. And so you can have a single number in a matrix which would technically have one row and one column, and it would still be considered a matrix. Now remember, rows go side to side and columns go up and down. And so when we identify a matrix by its dimensions, by its rows and columns, what we're going to do is we're going to put the rows first and then the columns second. And so we're going to say that matrix A is a 2 by 3 matrix, kind of like if you were taking measurements of a room or of a piece of wood or anything like that. And so we use that little X symbol. It's not a multiplication symbol, it's not an X variable, but it's just a way to write measurements. And so this is a 2 by 3 matrix because it has 2 rows and it has 3 columns. And those numbers can be any integer, actually any real number that we're going to deal with. So most of the time we see integers. Every now and then you'll see some decimals and fractions. Just be prepared to deal with your standard numbers that you've been working with to now. Okay, so we can see some basic examples here of specific type of matrices. So you can see this first one is called a row matrix because it simply has just one row. The next one is a column matrix because it has one column. Now, a square matrix is a very important matrix because that is going to come into play later when we start talking about inverses. And so understanding what a square matrix is, and of course this is a 2 by 2 square matrix, which is a very popular matrix size. We could also have 3 by 3 square matrices, we could have 4 by 4, and so on. Then we can have the zero matrix, and that's like multiplying anything by 0. If we have a zero matrix, it's all zeros and it has a similar effect. Now, if we want to say that two matrices are equal to each other, they have to have the same dimensions, and the parts in each part of the matrix have to be exactly the same. So those are basic terminology surrounding matrices, the basic setup surrounding matrices. Now what we're going to focus on the rest of this set of notes is the operations surrounding them, like addition and subtraction and multiplication. And each one of those operations has a specific rules that go along with when you can and when you can't do it. So you need to pay real close attention to that. So we'll go ahead and stop right here, and in the next video we'll start learning how to add and subtract matrices.